perform laboratory work only when your instructor is present. That means I don't want you in here when I'm not. Okay? Unauthorized or unsupervised lab experimentation is not allowed. Students are only permitted in the lab during their scheduled classes. Now, if you are dying to go over models, say there's a brain test coming up, you have to go to parts of the brain. Say there's a bone test coming up, you have to go to parts of the skull. Where could you find models to study if I'm not letting you in here?
The library.
The library. Very good. Very good. So you guys know where it is? All right, next. You are required to wear safety goggles during lab sessions with splash hazards. Now, thankfully, we don't have much of that in anatomy. Chemistry is like an all the time thing, you know. Example, heating chemicals in a test tube. You know, they kind of bleh towards the other person. You don't aim it at other people, you know, off the side. Or working with liquid bacterial cultures. I have some bad news for you. This room is used for every lab has goods and bads at this school. I love the Elmo. If I haven't turned it on, I will be. This overhead projector, oh yeah, it's on already. I will be using this all the time. When I dissect a rat, I will do it there, so it'll be projected on the screen so you guys can see it. When I find, oh, this is this part of the brain, this is this part of the brain, I'll be doing it on the model there so you can see it. Then I don't have to do the, hey, everybody gather close and breathe each other's breath that might be COVID. Instead, I'll be like, oh, see the thing, stay where you are, use your own model, but see what I'm doing, you do the same. Does that make sense?
Yeah.
So I love the overhead projector in here. On one of the other campuses that I taught at more recently, they don't have an overhead projector, a document camera. It sucks, okay? But like this campus, we share the lab. That's what I was rambling towards. We share the lab with other classes. We share it with microbiology. There are bacteria everywhere. Okay. If you go to West Campus, there's a lab for micro, and there's a lab for AP1, and there's a lab for AP2, and they are not shared. This is a lab for this class, and that's glorious. So every campus has some good, some bad. I really like the Elmo here, though. It's spectacular. But now I'm done with the or working with liquid bacterial cultures. We don't make those, but other people in these rooms do make them, and they do work with them here. Later on, when I talk about you should always clean your surface area before you leave, that's what's in the rules here. It should actually say you should clean it before and after you leave. When you get there, clean it so you don't be working with the bacteria by accident, and we don't want that. Everybody good? All right. Let's see. Wear appropriate clothing and shoes in the lab. Confine long hair, footwear that exposes any part of the foot, example, flip-flops, Crocs, sandals, not appropriate. Come here. Demonstrate your inappropriate footwear to everyone. This is your only warning. If you are wearing those in lab again, you will be thrown out.
Got it.
Okay?
Yep.
Even if we're not doing dissections, you just in principle. Because I have to, if I want a job, I have to obey the rules. I have to make you all obey the rules. So you'll have to. Okay. Now, go ahead, you're fine. I don't want, last time I actually did a shoe check, didn't I? Walked around and did a shoe check. Okay. Now, what you're doing with your hair, spectacular. What you are doing with your hair, don't. Okay? I'll make it very clear. Yes, exactly. That's it. See the haircut? I'm quick. If you need it, I'll give you a haircut. Okay? That's your only warning. Hair will be worn up. I'll go through lots of hows and whys later, but I think it's pretty straightforward. We already established we share this lab with micro. How would you like to be like, you're down, you're working on your dissection, your hair is hanging down on the desk that's covered with bacteria because they didn't clean it up? No, not good. Does that make sense? Yeah. Okay. So if your hair is long, wear it up. I know it's a little bit of a pain, but it also keeps it off your neck and feels better. I can say that from first-hand experience. When I was taking these classes, my hair was down to here, so much longer than yours. Yes, I wasn't always the jolly old fat man with the short hair. But anyway, enough of that. We don't have time. Remind me later and I will try to find the photo of me. Yeah, you know the photo. The one with the harp seal? Yeah. Okay. Let's see. So, confine your long hair. Footwear that exposes any part of the foot is not acceptable. I actually heard a story about somebody who dropped a scalpel It came down on a crock and went through the little hole on the top and went into the top of the foot with formaldehyde and pig juice. Now we use rats, not pigs here, but yeah. So it wasn't us, it was something I heard of, but extra disgusting. We would all agree, extra disgusting. So don't do that. Wear appropriate shoes that cover the top of your feet. Do not eat, drink, chew gum, or apply cosmetics while in the lab. Water bottles are not allowed. No food or drink containers are to be stored in lab drawers or cabinets. Keep these in your book bag or dispose of them prior to entering the lab. Now, I will tell you that's something I really like in West Campus that we're not doing here. They have a rack, like a rolling cart, but multiple, and everybody puts their bags on that so they're not down on the floor, okay? But regardless, we wanna make sure people don't trip over your bag. But this other thing about the drinks being in your bag, that's 100% accurate. In fact, I'll demonstrate it. Oh, I'm good. Oh, I was gonna get mine out of the bag. We both brought things in bags. What do I do if I want to drink them? I already did it once. You go out of the room, okay? Everyone good with that? So I'll tell you right now, you bring the water bottle with a screw top container, and especially if it's away so nobody sees it, I'm totally down with that, as long as you drink it outside. Don't drink it in the room. Ask around, the rumors are true. I yelled at someone for drinking in the lab in spring semester on West Campus, enough that they cried and were very cross and left the lab for the rest of the day. Don't make me put on my GER face. just drink out in the hallway. It's not that much of a sacrifice. At least I don't think it is. You good? Yep. Okay. Also, I want to add a story here. I told this one earlier, but it's true. It wasn't at this school. This one I was teaching at a different school. I was doing a stuff in the lab. And I'm like, oh crap, my class starts in 5 minutes. I have to leave everything. I have to run. And they made it to the lecture on time, and I gave my lecture. I'm like, now I have to go clean up. Because the thing I was doing, well, you're about to hear what I was doing. I was like, I have to go clean up the mess. I can't leave the mess. So they'll be on my case for that. So I go back and just my luck. The lab's being used by another prof and their students. And I walk in, and there's a student sitting at the desk. It actually was the first one on the left side. It wasn't in this presentation, but they're sitting there and they have a sandwich out and they have an open bag of chips and they have a drink container, and it is not a screw top one there. It's one of those snap-on like Subway cups with the straw, the kind that funnels all the bacteria down inside. And I looked at him, I know you're not drinking there. But, oh, he doesn't care. He points at another prof. I'm like, I don't really care what he thinks. Let me break it down for you. I was almost late to class, so I didn't clean the surface before I left. You know what I was doing? I was streaking plates with bacteria. Your entire surface is covered with bacteria, except that now it's on the sandwich that you've been eating, and in the bag of chips that you've opened up. It's probably in your drink too. And the kids and looks at the other prof, and they're like, he's not lying. And they go and they throw all their stuff in the trash. Don't be that person. Eat and drink elsewhere. Does that make sense? Yeah. Okay, so we're done with that. Never taste chemicals. You might be like, oh my God, who's that dumb? Everyone in the 50s was that dumb, okay? This is not a thing now. This is a thing that the lawyers require to put there so we don't go back to the bad old days. Does that make sense? I'll tell you how they did it in the old days. Oh, kind of sour. I bet that's an acid. Okay? Or, I really shouldn't do that with my, and then they would taste, and like, oh, this is bitter. That one is a base. Well, you know that without. If you've been exposed to an acid in the lab, you probably start itching. If you start itching, it's time to wash up. Time to clean up and then clean space. If you suddenly feel slippery for no reason, kind of like you have soap on your hands, but you haven't been touching soap, that's a base. It's dissolving your skin. I'm not making it up. You need to treat that. Does that make sense? If these things happen, you tell me about them. We have a chemical spill kit there, and I'll be honest, I'll probably, I may bring in some vinegar and some baking soda and keep them under the cabinet, because that's the fast way to deal with something like that. If you feel itchy, you sprinkle some baking soda on your and then you rinse it off, and then we do the cleanup after we know we've already neutralized the problem for you. That's my opinion on it. Anyway, but in the olden days, yeah, they used to taste things to see how they were. Next one, smell chemicals only when directed by me, by cautiously wafting the vapors towards you. Has anybody in here ever worked with swimming pool cleaners? Yes, no? Oh, yes, okay. You've heard of muriatic acid. Mm-hmm. Here in labs we call it hydrochloric acid. But you've seen it, you've experienced it. Have you smelled it?
No.
Oh, I may show you the video later of me working with some and accidentally getting and inhaling some. It's pretty potent stuff. What it is like 12 molar hydrochloric. It's strong stuff. It's not like nitric acid bad, but it's bad. Okay. If you open up a bottle and you have to see what it is, that's what they mean about waft the vapors towards you. Don't go up and take a whiff, because it will burn. It will be that. Like a little bit diluted by the surrounding air. You can smell what it is. Does that make sense? That's what they're talking about waft it towards you. Okay. Know the locations of the nearest eye wash, safety shower, fire blanket, spill cleanup chemicals, and emergency exits. So let's talk. Sorry. Emergency exits. They don't have the. Why did they not say first aid kit? Well, I'll find the first aid kit and show you anyway. It's right there. So this is a safety shower. This is an eye wash. I will not demonstrate either of them right now because it's very messy. Okay, but it will spray lots of milk. If you put the eye wash station on, it will squirt water over there and over there. It will not fall in the swimming pool thing. It will squirt hard enough to peel your eyelids back and pull your contacts off. Okay? You probably shouldn't be using contacts in the lab anyway. I stopped wearing contacts when I got around to spending all my time in labs. So, anyway, so you know where the eye wash is. You know where the safety shower is. We agree? This is the fire blanket. These all come together. We'll do a little story to show and tell about in a second. These spill cleanup materials are here, right? Emergency exit. We have 3 ways out of this lab. External hallway. Internal hallway. The other lab. This door will take you into a prep room and it won't take you out. Does that make sense? So don't have to go there. So that's how you get out in case of emergency. We have a very complicated system. We plan on going away from the fire. If there's a fire, we will take the emergency exit that is away from the fire. It's pretty simple. I guess I just lied when I said pretty complicated. It's pretty simple. All right, now I am going to tell you something about the fire blanket. It's labeled fire blanket. Probably should say fire blanket and modesty blanket. I've only used one of those once. I've heard one story about someone else. I was proctoring a test in microbiology, and it was the end of the semester. It was finals. And somebody said, oh my God, my grade's right on the edge. 2 letters is right on the ball. I have to go to the test. I can't miss the final. They were wrong. I'll give you a hint. If your choice is to leave the emergency room where you're waiting to be seen to go take a test, I don't want you. Is that clear? If that is what's happening, we will find accommodations to avoid having you come and get everyone sick or have problems. So I'm giving this test. It's like here, you'll move from microscope to microscope. The micro people are moving around. This person blacks out, falls, and smacks their head on the corner of the desk. Hits the floor. I'm like, oh crap! I go hit the phone, 911. I need an ambulance. And so, of course, they come. By the time they get there, she's come to. She's standing up, and they're interviewing her, talking. I mean, keep moving. You move from station to station. Ignore her. Keep taking your test. So I'm kind of crowd controlled, but she's talking to the EMTs. She blacks out again and falls and hits her head on the floor. This person clearly shouldn't have left the ER. She didn't need to be there. And the EMT is, I don't know, can you cancel the test? I need to take her shirt off and do the EKG thing and check her heart. And I said, I have the solution. Y'all keep taking your test. And I walked over to the fire blanket. I went over to the EMTs and I said, you take that corner. I've got this one. You check her. All right, everybody keep taking your test. Don't look over here. We had a privacy curtain. It works really well. So that's the only time I've ever used one. Not for fire. Good to know. I heard about one other person who used a fire blanket, and it was also as a privacy curtain. This was in Texas, and it was a chemistry class, and it was a high school. And a girl got a strong acid on her shirt, on the front of her shirt. I don't know why a teacher would give someone in a high school class a strong chemical. We usually use diluted things for that. Anyway, they did. And it was bad. She got bad enough problems from it that she ended up getting skin grafts. And let me explain why. She went over to the safety shower to wash the chemicals off of her skin. The right thing to do would have been get the clothes off that have most of the chemicals in it. But of course she's modest and she's embarrassed and she's worried. But if you had a privacy curtain, it would have been really well. Unfortunately, it was a male teacher who also went running looking for a female teacher to help her, and then he ended up getting sued by the parents for her money for the skin grafts because he didn't deal with it right away. The way to deal with it is you get two female students, say, here, you watch over her. I'm going to make sure the boys stay over there on that side of the room where they're supposed to. Privacy curtain. Fire blankets are wonderful and not just for fires. I'm done with my sermon. Everybody good? All right. All right, so we got that. I told you where the emergency exits are. Check the chemical labels twice before use. What are they talking about? We probably don't use much. We're dealing with models and rats. But if we do work with a chemical, it'll have a label on it, diamond-shaped, yellow, red, and white. It's called an MSDS, the Material Safety Data Sheet. And it has little codes on it in the squares. You look them up in the folder that it's talking about this with. It's an MSDS folder. This tells you for every chemical, these are the things that are bad about it. You should know about it, okay? So where it says you should check this first, you should. You should. And I don't have a problem with that at all. If you say, I want to see the MSDS, I'll go back through that door and I'll go get the folder and say, here it is, look it up. Okay? Not a problem. And I will tell you, I fully support people looking up. There are some chemicals that we use that probably are not normally a problem, but they might be. I'll give you an example. Suppose you're preggers. Do you think you should be sitting next to the bucket of formaldehyde with the fumes? I don't. I would fully understand if you say, I want to sit on the other side of the room that I don't normally sit on normally. I don't want to be near that. That makes perfect sense, you know? So yeah, look at what the hazards are. Make sure you know you have the right, that it's right there. And if you feel uncomfortable, you move. Now, I do want to point out something earlier. I think I missed over. You're required to wear safety goggles during lab sessions with splash hazards. One of the things I didn't say is there is a thing. Now, this is mostly in special senses, AP2. Anytime you dissect, you could splash fluids. You agree? Anytime you dissect eyeballs, you probably will splash fluids. Okay? So AP2 special senses, you cut open eyeballs, they might squirt. I would probably be interested in eye coverage then. I kind of have it built in anyway, but I wouldn't mind having some more. If you want something like that, I'm fine with it. But try to tell me in advance instead of like at the moment, because if you ask me right now for them, I'd be walking around like, where did our lab manager put our eye goggles? If you tell me 2 weeks before, I'll have them ready for you when we're time to do the dissection. Does that make sense? Yeah, okay. So we got that. They didn't say the emergency exit, but the emergency exit is through the, I said emergency exit. First aid kit, thank you for that. I was trying to think of, I was like, aid, but what, yeah, first aid. I said, first aid kits through the door and around the corner. Last lab, I actually made someone walk there and tell him, is it there? He's like, yes, it's there. I'm not going to do it again. I'm too lazy. But you understand, we have a first aid kit there too, okay? Anyway, so we got all that. Do not force glass tubing into rubber stoppers. Do not force glass pipettes into pipette pumps. All right, pipette is like a very tiny suck up amount of fluid, move it to another container, put it out. They're used a lot of times for measuring ultra tiny measurements of fluid in labs. In the olden days, we tend to use glass ones because they're reusable, but they also can shatter. So we moved away from that for safety's sake. We tend to use disposable plastic ones now. It's a little worse for the environment, it's a little better for your face, a little better for your hands. You get the idea. Okay. The first thing there, though, do not force glass tubing into rubber stoppers. This is one of the few things in here in the safety world that I've seen firsthand when it went wrong. Now, if you have to put a glass piece of tubing into a rubber hose, the way to do it is to line the end of the tubing with, if you're in a fancy place, with some glycerol. If you're in a more modest place, I've always used soap, which is mostly, what's the G word? Glycerol. You're supposed to say glycerol. Okay, but you understand. You put a little bit of that on the tube, and it usually slides into the hose without a problem. But there's some other things you do. You hold it right by the tip of the tube, so it goes down. If you hold it way back there and you're pushing, you agree you're moving this glass tube up and down. Glass is not always so flexible, so at least not at reasonable temperatures. So if you're wiggling this up and down, here, let's do this more accurately. If you have this long glass tube that you're wiggling, you're trying to put it into the hose, and suppose you hadn't lubricated, you're pushing, you got some force behind it, right? I saw someone doing this, they were holding it at the end, not up here at the tip where they should have been, and they were flexing the glass tube. What do you think happened? It snapped right in the middle, and they shoved the jagged edge through the thumb web and out the other side. Blood all over the floor. And I was kind of saying, oh no. I'm running down to the dean, and look. It was interesting because the dean's office, they called the safety people, campus safety, and they came with lots of paperwork. And you know how much paperwork I had to fill out? None. The student had to fill out a whole bunch. And me, they're like, you go back and supervise your students, make sure no one else does bad things. I'm like, okay, yeah, I'm done with that. So you don't want to be the paperwork while bleeding on the floor person. Do we agree? So if you have a glass tube and a rubber hose, you lubricate the tip and you hold it close and you slide. Or better, you ask me and I'll do that. And then you don't have to do it. I'll do the scary thing. Good? Yeah. All right, so we got that. Let's see. Examine all glassware before use. Do not use chipped, cracked, or dirty glassware. Let's talk about a crack in glassware. You might have a piece of glassware and it's holding a chemical. Maybe it's an organic solvent, but you have it, you're warming it up, and what happens when you warm up a piece of glassware?
It cracks sometimes.
Well, it cracks, but you were 2 steps ahead of me. You're my favorite now. Name?
Ethan.
Okay, Ethan. All right, let's get there in baby steps. Do glass things normally expand or contract when you get them warm?
It would expand.
They would normally expand. So if you had a hairline crack really thin, didn't go all the way through the glass even, it could still hold water or some other fluid. Would you agree? Mm-hmm. But if I warmed it up, what might happen?
It'll break.
The crack might finish penetrating all the way. And then you would leak flammable fluids out of the, it would be bad. Do we all agree? Thank you. All right, so Ethan got it. You got the memo. You know how to do this. Okay. All right. So if you warm up a piece of cracked glassware, there's a good chance that it'll break. And if it's holding something you don't want to have spread about, it would be worse. Are we on the page? Yeah. So chipped, cracked, or even dirty. You know what dirt is? It's residue of previous stuff that could be flammable. We don't know because we don't know what it was. So we want clean glassware, we want uncracked glassware, that's what we do. All right, so you examine it and you don't use it, you ask if there's a problem. Report all spills and or equipment breakage immediately to me. All right. Sweep up broken glass immediately and dispose of in the broken glass box, not the wastebasket. Let's demonstrate. Oh my, we even have the God, Heather is so good. She totally ruined it. Okay, this is a broken glass container. Everyone agrees, right? I was attempting to rattle it so you could hear, oh my, it really has broken glass. She cleaned up and gave us a new one for the semester. So there's no broken glass in it. But anyway, so it's lined with a trash bag, so and it's safe and it's good. And we use this to the little dust broom and the pan to pick up the broken glass. Does that make sense? Yeah, okay. Why do we not put it here in the normal trash?
When you take it out, it gets burned.
I like it. Name?
Tesla.
All right, Tesla. She said if when we're taking out, it could break the code. Let me make it more clear. If you were, say, the janitorial staff, and maybe we didn't use a clear bag, what if we used a black plastic bag? Just squeezing the air out and twisting it. Will you agree that you could have jagged edges come through the glass, through the bag, and into your hand, and then we could get sued? And we don't want to do that. We don't want to hurt the people who don't bleeding on our floor, and we don't want them suing us. So instead, we put it in a rigid-sided container that surrounds the bag. And when it's time to throw away the glass, let me get my finger out here. There's a flap. Do you agree? The flap that says, oh, don't put your hands here. We will tape the whole dang thing shut, tape the top, and we put that out. And nobody has to touch the fragile plastic bag with the broken glass, and nobody impales themselves because of it. Does that make sense? Mm-hmm. Yep, okay. So you got that. You know where the broken glass container is, though, right? You know, oh, I do have a little tiny bit of broken glass. You agree it's a broken glass container, right? Okay, good. You got that. All right. So if you break something, you report it to me. That's how we cleaned it up. That's where it goes. Good?
Yeah.
All right, so that's solid. Let's see. Report all spills. Yeah, we did that. If you are injured in any type of accident or a fire occurs, immediately notify me for assistance. Don't stand around, I can put out the fire, and then let it get worse. We'd rather have you have everyone leave and have someone else put out the fire. That seems logical. Okay, when mixing or heating chemicals in a test tube, point the tube away from people, not towards people. Why? Because what if the stuff in the tube expands and goes blip towards the person? They probably will be having a bad day. Okay. With sound effects, I promise that's exactly the way it works, always. Okay, never leave Bunsen burners or hot plates unattended when in use. Let's say you have a warm hot plate and let's say you're really irresponsible and you leave a beaker on there and you go to the bathroom. You would agree it could boil over and cause all kinds of problems. Let's say you're more responsible, you set the beaker aside with the beaker tongs, but you don't turn it off and you leave to go to the bathroom. What color is a hot plate when it's not warm, when it's cold?
Black?
Usually
Black
white.
or white?
Usually white.
Okay.
What color is it when it's really, really hot and it's boiling that beaker?
White.
It's still
Same
white.
color.
Most of them don't have any color change. So since if you walked away and you left it hot, somebody might walk up, maybe someone ebullient and loud and obnoxious, maybe me, and and you lean back on the table and there's a hot plate there, and it would be bad. It'd be very bad. So you don't leave hot things hot. You unplug them before you go. If it's a Bunsen burner, you turn it off. Does that make sense? If you look right here, you turn the thing off. We thankfully are not using any of that stuff. The micro people do, because they start the Bunsen burner and then they do what's called flaming. You take the wire loop that you're going to transfer the bacteria with, and you sterilize it in the flame, and you let it cool a little bit, and then you get your bacteria, you smear them on the plate. But we're not doing that, so that's no problem. We probably might use hot plates like when we talked about digestion and denaturing enzymes and stuff. We could use them then. We don't want to burn each other. Everybody down?
Yeah.
Okay, so we got that. All right, most organic solvents and disinfectant sprays are flammable. Why did they mention that? Because you should be pretty careful as you get them next to the Bunsen burner. You probably guessed because it's the same bulleted list. Okay, everybody good? All right. Do not dispose of chemicals, dispose of chemicals as directed by me. Don't put any solid materials down the sinks. When I was in middle school, I had a friend who dissected a frog. We had to do frog dissection. He had a female that was full of eggs. And he decided the way to complete the dissection was not to deal with all those eggs, was to run them down the drain of the lab sink so the abdomen was clean and easy. And do you imagine how happy the instructor was when the sink backed up with decaying frog eggs? It was Borton, by the way. Yeah, I know. Anyway, so yes, that's a real thing, and don't do it. Are we clear? Don't put any solids in the sink. If it backs up, it'll probably back up very badly and not good. All right, do not put any liquid waste in waste baskets. Yeah, that's just messy and nasty, and it'll leak out and then it'll get into the now. Liquids, if they're safe to put in the sink, you run them down with a hell of a lot of water. Good? But a lot of them aren't safe to do, so let me keep reading here. Check all waste labels twice before adding your waste to the container. What I'm saying is there are a lot of things, now this doesn't involve us much in biology and anatomy, this is mostly a chemistry thing. But a lot of times we have a container, this is where acids go, this is where bases go, this is where sulfates go. And you put the waste in the appropriate kind of container. You don't put the bases in the acid because then you have, you're right, does that make sense? Okay. So you might have specialized containers for certain amounts of waste. We actually do have one here tonight. You see the biological hazards one there? Over there in the corner, right there, orange with the biohazard logo. You know, like the crappy 80s pop band Biohazard? Yeah, I'm sorry, it's a metal band, not pop band, but you get my drift. That right there, any dissectable in this lab, it's gonna go in there when you're done dissecting on it. Whether it should be there or not. Because it's always better to err on the side of, you don't touch that, that might be dangerous. In reality, many of the things we use in this lab, like for instance our rats, they are in, I'm gonna use a brand name here, I'm not advocating Carolina Biological, it's just a company that does lab supply stuff. But you can buy things that are preserved not in formaldehyde, but in Carolina Perfect solution, okay? And we do that for some things. Some others we may use formaldehyde. It depends on the price difference. What it really is, Carolina Perfect or whatever, CaroSafe, it depends on the brand. They pickle the dissectable item in formaldehyde, formalin, just like normal. But then they take it out. And they put in something that inhibits bacteria, but not as well. So it doesn't preserve as long. But the important thing is it's not nearly as dangerous as unsafe. A good example, the CaroSafe I was talking about, they would take a pig or whatever, they preserve it like normal in formalin and formaldehyde, then they take it out, drip it off, and they put it into a bag of ethylene glycol or a bucket of ethylene glycol. Now, those of you who play with cars, you know what I'm talking about. Those of you who play with airplanes, you know what I'm talking about. If you're an airplane person, you would call that wing de-icing fluid. If you are a car person, you call that radiator fluid. It's the stuff you don't let your dog or cat or neighbor's dog or cat come close and drink because it'll poison them. Yeah, so it's not safe. I'm not saying it is. But it breaks down in landfills really quickly. So it's safer than formaldehyde that stays and stays and stays. Does that make sense? So if you order a dissectable from a supply house and you order it in one of these low formalin solutions, they technically don't have to go in there. They could be disposed of under most schools' policies in normal trash. But we think that if you put a bunch of cut up eyeballs in there, even if it was right around Halloween, it might gross people out. So you just put them in where you put the other. Then you don't have to worry about, well, did I remember to tell the students that this one doesn't have to go, this one goes in normal trash and this one goes in the biohazard. Just treat it all like biohazard. Good? So that's the state we're in. That's what they're talking about. So we do have a specialized container for biohazards. Now we're back on track. So we did the check all labels, put things in the appropriate waste container. Organic solvents are never to be disposed of in the sink. That's because they're those flammable liquid things. Waste containers will be provided as needed for their collection. 100% true, read the labels. The problem with these is not that they'd go down the drain badly. They go down the drain really well. And then they'd pollute the drinking water wells in a 3-mile radius, and then we'd get sued. We don't like that. You would agree that's bad. Poisoning people, bad. The general air pollution of venting all these things up, bad. So put them in the appropriate container, let the professionals haul them away. All right. Use fume hoods as directed. Never place your head in the fume hood. I like that. You were looking around. Did you see a fume hood? I didn't either. Does this sound like something they might be using as boilerplate verbiage that they would tell the chemistry people who use fume hoods? Yeah. We don't have a fume hood. We're not going to be using that many horrible chemicals. But if we had a fume hood, don't put your head in it. Good? All right. So this lab, no fume hood. Do not immerse, Ethan, can I ask you another glassware question? Okay. What happens if we get glassware hot? Good glassware, no cracks, I'm not talking about that. Get it hot, does it expand or contract?
It would expand.
Okay, so if we have hot glassware we're dealing with, and we got one side of it cold, say maybe we ran cold water on it, what would happen to that side?
Hot glass, cold, it cracks, right?
Yeah, well, I was hoping you would be a little more verbose, but I'll run with it. Pretend this is Ethan saying this, okay? So if you have hot glassware and you get part of it cold, like you run cold water on it, the hot part is expanding and the cold part is contracting, and you put stress in the middle of the glassware, and what happens?
Then it would crack.
Then it would crack. Does that make sense? Yeah. So do not run cold water on hot glass. Now I'll tell you the truth. The details are not in the safety sheet. Most laboratory glassware is not ordinary glassware. Most of it's what they call borosilicate glass. It's a little more durable. When I used to be a lab manager and people would drop something and it would like bounce instead of shattering, we'd be like, oh, that's good glass. It got to the point that we started calling borosilicate good glass. And when someone, oh, we need a beaker, do you want the good glass or do you want glass? Borosilicate's a little more durable than some of the glasses. You can still shatter it that way if the temperature differential was high enough on the hot and the cool. But if they were similar temperatures, it'd probably survive. Okay? Dow, Corning, some of those companies that make professional glassware, they do that. If you buy the cheapest stuff you can get from the cheapest vendor, it doesn't do that. Clear? Okay. So do not immerse hot glassware in cold water, as it may shatter. Yeah. Do not place hot glassware directly on countertops, as you might set them on fire or leave burned, charred rings, and it looks bad. And it smells bad too. It doesn't smell quite as bad as human hair set on fire in a Bunsen burner. Ask me how I know. But it does smell pretty bad. Okay. Let's see. Do not place glassware on countertops to do that. Use an insulating pad, which also serves as an indicator. I would have called that a warning to others that the glassware is still too hot for them to touch. Good? Good. All right. Keep laboratory areas and supplies clean. Store equipment in proper areas. Wipe down the work area before leaving. Good? All right. And now I'm going to remind you, I already said, who do we share this space with in the school?
Every other lab.
Well, yes, every other lab, but specifically those micro people. There are AP2 people and there are micro people. We share, this space is used by a lot of people. They'd also be mad if we set the counter on fire. But anyway, so remember, yours is not the only lab using the equipment. When you're asked to finish with lab, make sure the prep cart and lab look clean and as organized as possible. Good? All right. Would you agree that we have covered the entire sheet with the exception of this last couple of rules that are underneath the heading, additional rules for microbiology, and that's not us. Okay, we are now done with this lab safety sheet. You are going to keep this lab safety sheet. You're not going to give it back.